Alright, we're looking at a couple of things here using ratios, and we're going to use ratios. We're going to set up something we're going to call proportions here. Equivalent ratios are like equivalent fractions, but written in a ratio form. In other words, if all the terms are multiplied or divided by the same number, the result is an equivalent ratio. Remember the fractions we talked about multiplying at the top and bottom by the same thing. So here, we're looking for the first three equivalent ratios to 2/3. So the smallest one that's equivalent would just be twice as big. So if we times the top and bottom by the same thing, we get 4/6. So the first equivalent ratio to 2/3 would be 4:6. And we can think about it in the same way. If we're looking for the next equivalent ratio to 2/3, instead of multiplying by 2 on the top and bottom, we could multiply by 3 on the top and bottom, or we could multiply the first and the second number by 3, and we'd get 6 to 9. So that's an equivalent ratio. To find the third equivalent ratio, what do you think we're going to do? That's right, we're going to multiply by 4 for the first and the second number. So 2 times 4 is 8, 3 times 4 is 12, 8/12 is an equivalent ratio. So all of these guys are equivalent. We can do the same thing with 3-term ratios, 2 to 3 to 5. First two equivalent ratios, so 2 to 3 to 5. First, we could multiply by 2's all the way along, first number, second number, third number, and we can get 2 times 2 is 4, 3 times 2 is 6, 5 times 2 is 10, 4 to 6 to 10. Or you can multiply by 3's all the way along, and we get 4 to 9 to 15. Alright? So now, that initial ratio is equivalent to those other 3-term ratios. Just like we did with the fractions, we can talk about lowest terms. So 12 to 30, we're looking for something we can divide that by. I might just start with 2. I might not be sure what I can divide that by. And I'd get 6 to 15. And then once we're there, we want to ask ourselves, can we keep dividing? Well, yeah, in this case, we can divide by 3. So if we divide the first and the second number by 3, we get 2 to 5. So 2 to 5 is our lowest terms for our initial 12 to 30. Now, if you're quick with your math, you might be able to see that we could have gone straight there by dividing these numbers by 6. Dividing the first and second number by 6 would have got us all the way to there and skip that second step. Either way, 2 to 5 is the ratio you're looking for. Proportions then are a little different because now we're talking about it. We're looking at two equal fractions or equal ratios or equal rates. And now we're trying to figure out how to find something that's missing in this case. So I would actually look at it this way. That 5 is connected to the 25 by this factor of 5, right? In that direction we're timesing by 5. In this direction we're dividing by 5. So what we want to do with the 3 then is times it by that same factor, right? We multiplied everything, all the terms by the same number, or we divided all the terms by the same number. So 3 times 5 is 15, so 15 to 25 should be equal to 3 to the 5. And we can check. We said our factor is 5, so if we divide by 5, 15 divided by 5 is 3, 25 divided by 5 is 5, so it checks. Right? So these two are equivalent fractions, or equivalent ratios, or equivalent rates. We can do the same thing here with this guy. Look for the factor here, right? 9 divided by 3 equals 3. So in that direction we're dividing, in this direction we're multiplying, times 3. Right? We said these are opposites. This would be times 3 in this direction. So 5 times 3 is 15. This direction we're dividing. 6 divided by 3 equals m, which is 2. So what we see there, it's a little weird. We're going to do it a different way too. 2 to 3 to 5 is equal to 6 to 9 to 15. Right? In this direction we multiply everything by 3. In this direction we divide everything by 3. Another way to look at that might be to kind of break it up. We might just worry about the m, the 3, and the 6 and the 9. Right? So m to 3 is equal to 6 to 9. Or we could think that m over 3 is equal to 6 to 9. And now, just like we did with equivalent fractions, we can kind of see that division step a little easier. Right? We divide by 3 on the top and bottom, so that's how we get our 2. right? And it was the 2 that went in here. So you can break it up in pieces, or you can do everything in the 3 term, but there you go. Make sure you've got those examples written down, you guys. Make sure you understand what's happening with each one. Look over it again, watch it again, ask some questions if you're not sure. Once you feel like you got it,